Hi, and welcome to this AI and C# video, where we will be going into a mini series in 3 parts on how I use AI in real life outside this educational channel. So, what have I implemented in real life? What type of tools and so on are you using? So, the first video you're seeing right now is AI and C#, where we will look at how I'm using agent framework in various C# apps and services in order to get them agentic. Part 2 will be the reverse C# in AI, where we will look into what coding agents I'm using in order to help me write the C# code I write day to day. And part 3 will be other tools, AI tools that are out of the box, automations I use, and so on. So let's get into it. In total, when I tallied it up, I have 9 live use cases with AI written in C#. I have something for work and I have something for personal. So for work, I have a chatbot. I have some support related things with translations, summarizations, and suggestions. I have an AI pull request review. I have some changelog generation for review and of changelogs. I have code assists in terms of an MCP server I've made. Personally, I have my bank statement ordinal receipt matching, which was covered in a separate video, so we won't go into it today. Then I also have a coding assistant for my open source project around Trello. And finally, for the user group I'm managing, we have also the net user group. We have a MCP server for picking winners of our JetBrains sponsorship. So let's look at each one of these in more details. So the first one is the chatbot. So I made a chatbot and it's in Blazor server. So I'm not a front-end guy, so this is what I can make. So we have a small chatbot where we can ask a question and we can ask which kind of agents behind the scenes, a support agent, an internal agent, and a customer agent, which the user can be turn on and off. Whenever you press send of a message, it goes in and finds the models and the providers in general. Or almost everything I've done can switch between either Azure OpenAI or OpenAI on the fly, and everything is controlled up in this front end. What model we can choose, so I don't need to redeploy if I want to use a different model. In this case, I'm doing a sort of small multi-agent scenario where I first give it to a very small model that is called an intent agent. And as you can see down here, it's using structured out to figure out, is this question support related, internal related, customer related, and it needs to give a score between 3 and 10. And these 3 to 10 means that how many vector search records I want to get back in that kind of area. So if it's something that sounds like a support question, it will score high on that and get more support data, while it will get less of the internal data and customer data. So it's just a little scoring system I put in, so I don't spend too many tokens on the various things. So if someone asks an internal question, I don't want to load up a lot of support questions and customer data on the fly. But this has been then handed up to another agent that gets a lot of tools. It has a docs tool, it has a CRM customer tool, it has a support history tool, and an internal knowledge base tool. The docs tool is actually over to another system that have a vector store. We have a documentation page, and that documentation page has been vectorized with all its markdowns, so it can be searched for using vector stores. So there's an API for that, and I just query that and get the values back. And again, that is based on If it sounded like support, it takes a lot of up to 10 of the documents. If it doesn't sound like support, it takes maximum of 3 from here. That is how I controlled it down here, chance for the various stuff. I load it upfront and don't use it as a tool as such to ensure that these small models are capable enough of still calling the data. And this is a bit too many data tools for it to fail. It will often fail to also call one of the other tools despite various instructions to do so. So we load them up front, and that's the reason why we take 3 to 10. The HubSpot data, the CRM tool is HubSpot, and we actually do live calls against that when we need it based on some filtering. And then the 2 others are vector stores controlled by the same side as the front end, which takes a lot of support data from Slack and turns it into records in MS SQL that is then being vectorized. And the internal knowledge base, which is also a Q&A system that is being vectorized, and then we do vectorized search using the Microsoft Extension Vector Data System. So this is an example of that, and it's all the same that you have seen in the RAG videos as well. Moving on, I've made various things for support in support and translation summaries. So what we have is a Slack webhook that just uses the Slack NuGet package. And whenever that is run, we just enqueue the Slack message, save it in a SQL server, and store it, and then do some AI treatment so the Slack webhook doesn't time out. We're using something called Coraville for that. It's just a NuGet package. But then we do the agent translation and summarization, because certain of the support cases we get in is in non-English, and we have non-English supporters. So before the system, they sat and took the text, put it into Google Translate, and then answered. Now we on the fly get a model, an agent, and we say we want you to translate it into, if it's non-English already. We want you to figure out which area this is in, so for some categorization of the data. It needs to tell what kind of why this was a support case. Was it because the user didn't read the manual? The user couldn't find anything? What is the reason? And then finally do a simple summarization so it can be shown in a summarized form. And this is using, again, structured output, where we have this tool that it needs to be summarized, and it gives a description on how it should summarize, and maximum 250 words and so on. The English translation, and leave it blank if it's already English. And among the support areas, which one is the most likely, among the reasoning areas, which is the most likely. So once it's do that, we then go on to the next step, which is actually trying to answer the question. Only for internal use so far, but the last step here will be that an agent will try and suggest an answer. So we again from the database gets what model that's set up to be in general, take all such things and put it out into settings. And then we just make an agent. I think it's a ChatGPT-5 Mini that does this work. And it has a prompt. And this prompt is again in settings where we on the fly switch out these keywords, questions and description of the company and so on. And then it does the same search as the chatbot did into the same vector stores. So on the fly, it loads up data, and based on that, it should figure out how it should answer, and it just gives an answer back that we just put into the suggested answer. And that results in the page where we have our support cases, that the real message is over here, but there's a small summary of it, so you can see them up front without needing to go to them. The people who are not native speakers of other languages will get the auto-translated version, and we will see a small robot here indicating that this was an auto-translation. So you can switch between the original and the auto-translated. It then shows a suggested internal message on what was the answer to this question could be. And as we can see here, the supporter actually used it a bit in here to answer back, more or less copy pasting. Sometimes we want to make this actually answer the customer directly. And the final thing is the AI categorization. It thinks it's about filtering, which it is. And the why is unknown here, so it just says miscellaneous. Moving on, GitHub AI reviews. This is a quite normal thing now with GitHub Copilot, Codex, Claude Code, and so on. We just did it 6 months before any of them. So this was actually a blog case on the semantic kernel, which was the previous before Microsoft Agent Framework, but I have switched out the semantic kernel code to Agent Framework code, of course. And what happens is that in GitHub, when someone makes a pull request, the webhook is triggered, and my code, which I will show, or is shown in here, and I have a small highlight of it, is triggered. It goes in, gets the PR diff and additional data if we have any. It goes down and get the task related to this, in our case a Trello card that is linked to the pull request. It goes in and do the review using structured output. And again, it's not semantic kernel anymore, it's now Agent Framework. And in the structured output, it's being allowed to say, hey, I could do a better review if I had this, this, and this file as well, because a diff doesn't include all files. And if it asks for that, it redos this step with the additional files on the fly. When this case was run, it was using an O3 Mini, but now it's using ChatGPT-5 Codex instead. And this results in various comments on the pull request every time someone checks into something new. So there's self-review using AI before a human then sees it for the final review of it. The code is here, and this is the Agent Framework code. So essentially we just build up an instruction using the diff, using additional files, using what the task was about. And you can put in some extra user instructions if need be. And once you do this, we just use an agent, again, structured output. There's a reason why I like it so much. You need it almost everywhere, where I want to have a summary, I want to have the potential issues found, and I want what additional files would make sense for you to give. Next up, we have changelog generation. So whenever a user makes some changes, in this case some API changes to some abandoned cart triggers for some e-commerce, automations will put in a definition of done for this work, and among that it will make an add to changelog. entry that if the user or the developer presses that, it will go in and based on what they have written in the title here, what they've written in the description of the work, it will auto-generate what should be in the changelog based on this, based on some rules we have. And then they can go in and review their own do a little mini review of the changelog entry. So if it follows all the rules that we normally use for the changelog. The code behind this is very simple as well. We just get a model like normal. We get the instructions, and the instructions are fairly simple. There's some terminology rules, there's some guidelines, and what it should leave out, what it should prefix the data with, how the styling should be, and so on. And based on that, again, a structured output entry where it comes back and say what's the prefix, what is the text, what's the type, is it an addition, is it a fix, is it a deletion, and so on. So it just gives that back based on the input of the title of the task and the description of the task. Then we have code assisted MCPs. So this is an MCP server that we have built. And in general, it's just an MCP server that works with docs and source code. So all this code is in private repositories, but we grab the code. For example, via C#, we use the Roslyn engine in order to pass out what is the public methods, what is the public classes, and so on and so forward. In Java, we do the same. In PHP and TypeScript and JavaScript, we do the same. And for the documentation, we grab out the Markdown, which is actually the ones that are used in the chatbot as well. So we make this MCP server available just using normal model context protocol. And we expose it as a few tools that the system can then use. Behind the scenes, this is using something called SimpleRag. It's an open source MIT NuGet package that I have made. And it's built to hook up to a GitHub repository or a local storage of source code and turn it into a vector store. So you really just need to tell, here is my code, do the rest. Again, this is open source, so you can go up and check the code up there. So there's very little code involved in making this because this NuGet package takes care of most of it. The final few things I have is my private MCPs. I have a similar to what I just showed for the work part, in that I have a NuGet package called Trello.net, which is an API for the Trello Kanban boards. And there I grab the Wikidata that I have documented and the C# code and turn it into a MCP server that is running up in Microsoft Azure on Azure Functions. And then any developer IDE can enable this MCP server and get much more intelligent information about the products, because coding projects like this, which is a more niche thing, is not as known as some of the more popular NuGet packages out there. So this is normally needed. It's a little like what Context 7 does, if you know that MCP server, but it can be done for private repos. The final thing I have is a small MCP server on the group I'm leading, the Aarhus.net user group. And on every meetup, we have a sponsor from JetBrains where we grab a winner. We have a small Blazor site that can do that, of course, but given all the AI hype here, We also made a small MCP server that can do the same data, and so one can go to a coding agent or any MCP client and say, give me a winner for the latest meetup, and it will come back with a name. The code is open source, so you can just grab it from the nooktools.azure websites. So that is actually everything I have live. I've of course made a lot of other code in these videos and stuff like that, and I have more interesting and more advanced things on the way, but we will take them in the next iteration of such a video here on what I have live in the system. Most of these have been fairly easy to do. Some of them have just been a couple of hours, and then it was live. Others have been several weeks when I was early on learning this. But that's everything. See you in the next one.